been really hard to replace her. So we took a long time, and Connor Simon just joined us and started this week. Monday was his first day. So welcome him to the program, and we're looking forward to getting him started. He was well worth the wait because this is such a unique system, so we had to find a unique individual. So and we did. So and a good one at that. So
is it Connor? Or
Connor Simon. Yes, and since I introduced him, I'll introduce myself as well. John Lott, the program manager, and we'll just go around the table and hit everybody that's here. Yes.
The meeting's being recorded.
Yeah, that's a good point. The meeting is being recorded, so everybody be aware of that as well. Mike?
I'm Mike Conover, a professor at Utah State University. And Connor, I've got to hand it to you. You've only been here a couple of days. You already have a hat and a jacket.
We're ready to go.
I have been here for 30 years. Begging for a hat and a coat.
But if we gave it to you, you just spill something on it.
They don't want anybody to think that I might be working for DWR, which is very wise of them.
Exactly.
But I'm impressed. You should feel honored.
I appreciate it. I'm excited.
Anna Villa with NH Conservancy.
Thomas Bill Steels with Brine Cooperative.
Gary Belofsky, University of Notre Dame.
Kyle Stone, System Program.
Bill Brown, Brine Cooperative.
Christine Ramsey, USGS. Serena Seawolf, USGS.
Connor, yeah.
Danielle Aranda, GSLEP.
Lauren Head, Utah State University.
Kate Smith, Utah State University. Ryan West.
Chad Benny with Dominion Wildlife. I manage public and Salt Creek. I'm also John's assistant, but apparently I'm not one of the smart ones.
Marissa Wander, Movement First and Fire Statement.
Mr. Baxter, GSLEP.
Neil?
John Nielsen, I'm with the Great Selective Systems Program.
Also, and just so we get everybody that's online, John, you want to read those folks that are online off?
Yeah, I'll read David Richards, Erica Stuber, Ken Meyer, James Harris, Jeff Denlicker, Jennifer Wright, Lauren Upton, Leanne Chambers, Linda Freitas, Mark Bell, Paul Thompson, Rob Dubuque, and Robert Shields.
All right, so to get started, we're gonna start with Kyle, given the shrimp demographics. One thing I will mention, since I'm at least providing some praise to folks, Kyle's been covering for the lack of a biologist and handling basically everything for the last year. So he almost needs a standing ovation, if not some type of. Yeah. So thank you, Kyle, for really stepping up and handling essentially everything lately. So I'll let you go ahead.
Yes, where do you see? Here, okay. Okay. That's better. Your shit. Sorry, guys. You'd think after this many years, you would have this figured out.
Here's the problem doing things online. It's hard to figure it out, so it looks the
There we
right
go.
way. I'm good.
That looks good there. Everybody see what they need to see. Okay, so this is gonna be a quick update of our brine shrimp demographics here for August. So the basic layout of the graphs for this year, we started this year. Shamelessly sold to the USGS, just because this is a great way to represent our 25 years worth of data. So for you guys online, I try to describe the lines that I'm pointing to up here in the room. So the dashed lines at the top and the bottom represent the minimum and maximum observed at any given month for each of the individual parameters. So this one's going to be temperature here at the top. We'll move through all the different things. The gray shaded areas is going to be the 25th to 75th percentile. So that's going to be kind of our normal data set where we expect the bulk of the data to be. The black line running through that is going to be the average from 1999. So that's where we're going to be that 24 years now. The gold and yellowish color solid line is the previous year. So in this case, 2022. We're still going to talk about this little peak up here at the top. There's 3 data points that we were able to be shared with us from the co-op, because in 2022 through June and July and part of August, we were not able to access the lake due to the lake levels. So we do have some data to represent where this little flat line here in the gold section through June, July, and August, you get some kind of semblance of what that is. And then the red line is going to be the current year. So that's what we're going to be talking about most of the time is the red line. And we're mostly going to focus from August to December. So looking at lake temperature here, you can see that summertime, we had peaks of high temperature in the summer going to well above the 75th percentile, but nowhere near the maximum of what we've seen in the last 24 years. So it is quite high temperature, but nothing too drastic. As we move through the fall, you'll notice that we're more in that kind of jumping rope with the average line, staying within the 75th percentiles. But the real key is right here through late October, early November. You'll see that November we were on the warmer side of things. And that's really going to play into how our shrimp have responded with that warmer temperature will allow them to persist and continue to produce this, and just basically all the life stages to persist into our current time frame where we still have to on our last run. So we're still hovering, we're about 9.1, and we have the 27th of November. We do have one run in for December, but we're still in the process of counting and being shorthanded. We'll finish that tomorrow. Moving into salinity, you can see, so starting last year, you see the gold line at the top of the screen. We really set new maximums all of last year. Everybody's aware of the issues that we went through there. You can see when the adaptive management berm was raised here in February, and we get that peak runoff that we got this year. We saw a lot of inflow to the south arm of the lake specifically, and you really get that precipitous drop here March and April. And it really returns everything back to kind of the average condition for the last 25 years, where we're, sometimes just above the average, but very much well within the 25th, 75th percentile. And we carry that throughout the year. Much better conditions than they were last year, much more favorable to the shrimp. And everything seems to respond to that accordingly. We are starting to see that little bit of a peak going up right now. A lot of that's probably going to change in the next couple of months as we start to get a little more runoff at the end of the water year. So we're still currently sitting, on average 14.3%. Again, this is refractometer measurements of the surface. So for you guys that speak gram per liter, this is going to be kind of that. Our average is going to factor in those lower saline lenses, freshwater lenses coming into the lake. And we do have a few points that are right on the river inputs. So that's why our values are going to be a little lower. So 135, 140 grams per liter right now, compared to the 145. We're seeing, for example, which should give us a better updated what's really reflective of this.
So I think this is a shout out to Marissa and the Salinity Advisory Committee for getting us back into the right place.
Sure.
Because otherwise we were looking at some really dangerous.
Much happier. Moving into the chlorophyll, so you can see the black line in this kind of sends that typical trend where we get higher amounts of chlorophyll A in the springtime through the winter, because there's shrimp out there grazing them, and we're getting constant nutrient inflow to where they bottom out in the summertime and then tend to rebound more in the fall and winter time frame. So if you look at the red line right here, starting in September and October, we started to get that rebound. But with that warmer temperature and the persisting, the shrimp able to persist and continue to live, they're continuing to graze that down. So you get this little bump down here where they're actually grazing the chlorophyll off again. And it is starting to rebound. So we're starting to see a greener lake come through. But this is all due to that warmer water temperature allowing the shrimp to maintain and continue to graze. Currently about 3.9 micrograms per liter right now out in the lake. So you can see earlier this spring, we actually set a new maximum for March. We were up there around 75. So nice to return to some of these late 90s numbers that predate March and days. Cyst density here has always been suppressed. So we came into the season fairly low. You can see that red line's kind of right on that 20 percentile line, quite low. And then just never really recovered. Got a little bit of a bump in August, but then we got that big precip event. A lot of that hatched. So at the last meeting, I believe our August average was closer to 75. We had one more run come in after our previous meeting in August, and that dropped the average down to about 59. So we're sitting fairly low. We did hit 76 for a monthly average in October. We had a couple that were over 100, a couple were down to 60. So we're not seeing that peak production quite yet. It's likely going to be sometime in this late October timeframe. But where the shrimp are still alive and are still producing, not quite ready to say this was the peak yet. So we'll talk about that probably in the March meeting. But you can see just overall suppressed compared to the average. But overall, it still seems to be falling in line with the prediction that we made back in August, where there is this available. We're not probably going to set any records for harvest or records for availability of brine shrimp. But the fact that we do have brine shrimp, there is even anything going on. There's plenty of food for the birds with the adult members to look into. Yeah, going to get that shout out to Marissa and the Salinity Advisory. We saved this.
Really, Christine.
Looking pretty good so far. So the rest of these are all going to look kind of the same, where they're going to follow the same trend where you can see the black line peaks a little earlier. So on average, they tend to peak around May. The red line is going to peak late May, early June, and then that gold line last year we peaked really late in mid-June, almost into July. So it all kind of tends to tell that same story where we're still behind the 24-year average, but we were ahead of last year. So it shows that conditions are a little more favorable, a little more what they used to be, not that high stress, high salinity state that we had last year. So Naplii have been suppressed. I mean, they peaked at 6 per liter in May, and then they've just kind of been steadily down. That June, July, they really see that kind of flat bottoming out right here. A lot of that's probably due to our sampling regime, where we're going out every other week. We're probably missing a lot of those peaks. We're just not catching when they're peaking in between. Just we go out, it's a little bit flatter. But overall, you can see we've had naphthalate present all year. And even into November, we're still having naphthalate produced. Even the samples today are still all females that have eggs. So whatever they're doing, they still think they're going to survive. Even though we know better, right? Moving into the juvenile density, again, juveniles are really hard. It's a short life stage. It's hard to pick up for a sample regime. So, but it follows that same trend where they're a little bit later, not as late as last year, but then we get this extra pulse here in October and November where we're getting this final generation. Similar thing with males. You can see that some of this survivorship later on here in October and November, kicking off that next final generation here. But so far, everything seems to be either near the average or above for the most part. Female density looking pretty good. Females with egg density, you can see this really kind of odd shape here in October, November. There again, that probably leads back to that warm temperature, just kind of cool. If there is plenty of food, warm temperature, maybe they'll time to produce a few more live down. But you can see it's fairly low. I mean, we're talking less than 0.2 per liter, average of like 7. So it's really not affecting the bulk of the population. Because when you look at females with cis density, you can see that most of the reproductive effort since really July and even in September has really been put into cis production. With what looks like the highest number of females producing cis kind of being back in October, but they are still trying. And again, that same average, so you know, maybe a little earlier in cis production for the feed, but nowhere near as bad as last year. And relative amounts, definitely a lot of production this year that we have seen on average. Total adult density, again, this is going to be the same graph, just kind of sums it all up so you can really see a little bit higher scale. But it really follows that same trend. Even in the summertime, you can see the generational gaps here. So we get kind of our first generation there in May, almost like a second one here in June. It's a few step downs, pick back up in September, pick back up here, and then we'll see if this one in December actually gets to persist or will get cold. Or they make it. And with that, that's all I have for update.
Kyle, can you go back to your cyst count slide? So I think what may be happening, because our harvest is actually going rather well. I mean, we think year to date, if we compare it to 19-year average for our cooperative, we're probably around 10% above our average. And what I'm wondering is we had this really sort of synchronous peak cyst production, October, November. Often it starts much earlier, but this time it was really sort of, you know, a more synchronous production. And I'm wondering if we're just been sort of harvesting a significant portion of it as it's being produced.
And that definitely seems to go with, you know, what we're seeing. You know, we watch your guys' harvest reports and you're reporting, you know, millions of pounds a day. It's all tracking really well, but our cyst numbers just stayed relatively flat. We're very constant in that. So yeah, I'm wondering if you guys are just pacing with the harvest,
Maybe.
which is honestly fantastic.
Yeah, there has been times where the production outpaced the harvest even.
Yeah.
So, yeah, I think that's exactly what we're seeing.
Yeah, I think it is a good point that it is a timing thing because, you know, a lot of times we'll see this peak a little earlier, September, October, and then, you know, this year we're getting more of that peak later. And that's really shown in that females with cyst.
Yep.
Slide here where you can see it just every time we go out, there's more and more females all the way in November producing cysts.
And I think with larger brood sacks as well.
For sure.
Over there.
It's actually been way up. So that's the other thing with chlorophyll. We've had a lot to do. Anything else?
I assume we're not proposing that we call a timeout and let it catch up.
Not yet. No. When it hits 20, yeah.
Yeah. All right, so, go ahead, Christine. Christine's probably, so if we're gonna talk about superstars, she's the USGS superstar, because she's had to do an extremely,
The real hero.
right? Yeah, so that would be what I was gonna do.
Yeah.
I've been lobbying for Christine to get a raise, so if any of you have any ins with USGS.
Yeah, no problem. I said that, let's vote.
Hold the president.
Yeah.
No one opposed.
You got a real ability to solve it, but it, and then adventure, and that we can help everybody understand that better. So we're going to be getting our regular updates. I just want to highlight that our report on Great Salt Lake as USGS is a whole team of folks. It takes a lot of people to make this happen. Serena Siebel, I want to introduce her today. She's our hydrologist at our Water Science Center, and she's actually going to be doing a lot of the data analysis for next year. So we're going to kind of co-present today. And so we'll be going through lake elevation condition. Apologies for those who've seen that already. Basically, discharge monitoring, little water quality data, and then Serena will take it away with the data and data analysis tasks. So our most recent data for Saltair, so our lake elevation gauge representative of the South Arm, as of 2 days ago, lake elevation for 4192.3. Yeah, we're kind of hit our low, I think, for this season, and late October, early November was around 4192.1. So we're starting to see things gradually stabilize and maybe come back up relative to our high in the spring. We were down about 1%. So to give you an idea of how much drawdown we had this year. North Arm gauge and CAD is shown here for the last couple of years. Our most recent value as of 2 days ago was 4189.4. We didn't really see a huge increase in this tree. So we've actually started to see the North Arm come back up as it's pouring over the berm, but still pretty low. We look at inflows. I wanted to just give a summary of what are your 2023 conditions. So USGS computes these charts based on water year starting on October 1st to September 30th. And on the y-axis, we're showing cumulative stream flow to 26 feet, and we are flooding spots. The blue line is our historic high over the last 60 years at this site. Yellow, or this orange color, is our low, and then this green shaded areas are 20 to 70 percentile, similar to the last. And then the gray line is our median value. So for last year, we're looking at the Bear River near Corinne on this plot. We were actually pretty low last year, starting in October, November, as well as where it started low lake conditions. And then discharge started coming up in around February, March, April. And where we ended up last year was, higher than median values. If you look at Beaver River, similar patterns. We started off really low, and then we had our spring runoff, and then we ended up around 75th percentile by the end of the water year. Farmington Bay, Causeway, same thing. Started to see values come up a little bit earlier, maybe December, January, February. But we held steady, and we were really near 75th to maximum. Slow at Farmington Bay coming into late, and then Dog and Drain hovered around the median value here, and then it's or 75th percentile. So I don't know, it's very good water here. And we add up all those discharges, and these are just major surface water inflows. We also acknowledge other kind of trickles coming in that we're not classifying this time. But added together, we were sitting around 2.3 million acre feet for all of these. And just relative to that big year we had in 2011, that year's cumulative flow was around 3.66 million acre feet. So we hit about 2/3 of the flow of that big water. Great year. Okay, moving on to this year. So October 1st, 2023 now, moving forward, the black line is where we are now. And so starting with Bear River near Corinne, we have a continuous gauge hovering around the median of historic values. With Beaver River near Plain City, we're around the high or 75th percentile currently. Farmington Bay, we are near the median value also. And lastly, Dog and Drain, we're looking around So far, so good. Fingers crossed that things continue to hold as they are. I also want to highlight that we conduct discharge measurements of Bear Bay outflow. So this is distinct from Corinne. Corinne's above the refuge, so you know that's where it's kind of a more traditional stream flow site. We could engage there and monitor it. On the other hand, Bear Bay outflow, this is where the Bear River enters the south arm, kind of flows below the railroad crossway. So really challenging site to measure. It's about 500 feet wide. A lot of sedimentation is moving around constantly, makes the cross-section really difficult to characterize. Point being that we can only get measurements there discreetly. That means we take out basically a boat, an ABCP, acoustic Doppler velocity profiler, and conduct a measurement. We do that periodically. And historically, our contract has been to do that around 8 to 9 times per year. So these are just kind of our measurements from last year. We were able to get 11 measurements and really tried to hit the runoffs. Given that it was a big runoff here, we tried to get as many measurements as we could during runoff. The peak discharge we measured last year was from mid-May, and that was about 6,200 CFS at that outflow. We also saw a pretty high discharge in late March. So March 23rd measurement was around 5,700 CFS. So, and just to give you an idea, when we compute, salt mass balances or nutrient mass balances, we're really using that Corinne gauge. Here's a plot of discharge of CFS over time. The blue line represents our Bear River Corinne data, which is continuous, and then these discrete measurements at the outflow. So because we don't have continuous discharge at the outflow, we kind of use Corinne as a surrogate, and this is just to give you an idea of how those data compare. They're fairly comparable, but we do know that we're missing some information at the outflow. Okay, and then new breach, we conduct a number of different types of monitoring at that opening and the railroad crossway between the north and south arms. Monthly discharge measurements, continuous instruments, which measure lake elevations on the north and south sides of the causeway, weather sensors, monitoring things like wind speed, velocity. We have an uplooker velocity profiler that is tracking velocities at different depths in the water column each time. And these data are kind of all compiled and shared with our partners at Utah State as they're building a model to try and figure out how we can get continuous discharge at this site. Here's a plot of our most recent, our record of discharge at the new breach. So discharge in CFS on the y-axis. Here we're showing data from 2021 to present. We did see pretty good discharges from south to north. Those are the blue symbols from south to north. Throughout the summer, these range from about 1,200 CFS down to 900 in late August. And then we have measurements in October and November that were around 800 CFS. Our most recent measurement in mid-November was around 700 CFS. So we're starting to see it come down just a little bit. This has been pretty tricky to measure in the past, continuously, as I said, just because there's bi-directional discharge and it's tricky. But as the berm was raised last February 2022, we only really had flow from south to north. It made conditions a little more easy to be able to get at methods for getting into continuous discharge. So people have been exploring things like using broad-crested weir calculations. Our technician, Andy Carlson, is also trying to build a rating, which would be similar to a traditional stream for the site, given that the variables have been reduced, given that there's no flow. So many avenues are being pursued to try and get a continuous discharge event. Okay, so now I'll just kind of switch gears to our water quality monitoring program, which is the meat of our agreement with Grace Lake. Specifically, the TAG funds nutrient analyses at 4 sites in the South Arm. GSLEP collects these samples, 2565, 2767, 35. So we've got sites in the Gilbert Bay, Carrington Bay, and the outflows of the Bear and Farmington Bay. And then the agreement also funds nutrient monitoring at the inflows. So these kind of blue cross symbols at the Bear Bay outflow, Weaver River, Farmington Bay, Farmington, and we haven't tackled lakeside profile, given that it's dry and it's summer installation. So that's kind of what is in the GSLEP tag agreement. And what we do, we measure field parameters, nutrient density, salinity, routine. I will also point out that we have an agreement with the Division of Water Quality where we conduct sampling twice a year in June and October at sites in this orange square here. So 7 sites in the South Arm and then a few sites at Farmington Bay and Barrow.
Hey, Christine, I just thought of this when you mentioned Lakeside there. Did you get the salinity on that water that was flowing back in?
Yes.
When we were out on the causeway?
Yeah, it was around 50,000 microsecond per centimeter. And we haven't gotten the concentration yet. We're still working on getting it analyzed. But yeah, it was quite high. So this was, John's referring, we were out there, what was it, October? We were at Lakeside and there was just this huge water flowing in from the northwest. Near the salt flats, I would presume from within the basins, an immense amount of water. Anyway, we just grabbed our water sample there and the conductivity was really, really high. I mean, lower than Great Salt Lake, obviously south on or north, but really interesting in how high it was. I think that would amount to about a third or maybe a quarter of what the salinity of this. Really very high.
Yeah. Thanks.
It was going to the south arm of the north. Sorry.
Well, it was actually flowing into the north arm and then out into the south arm because it was going through the lakeside breach from there, probably from whatever the big northwest salt flats out
Right,
there. So,
exactly.
but we've talked about how that's, can be a sink out there, and maybe there's a possibility of collecting that water from Right Fall and getting it back to the lake. And if it's, depending on what the salinity is, maybe that's maybe we even put a berm on the lake sides, depending on what we want the salinity to be. But it's water that could be added to the lake in a productive manner rather than have it just evaporate in that the Bonneville salt flats. I don't know what you call that on the other side of the lake sides.
Yeah, it'd be kind of fun to get.
And it's so much closer than the Pacific Ocean.
Good point.
And cheaper to make.
Yeah.
And I kind of just wanted to take a second to just highlight what this nutrient monitoring, salinity monitoring does for management, or we strive to do. Is that, well, nutrient salinity data are two theories to help drive those are important components of what he's doing. And then the salinity data has become kind of instrumental to the salinity advisory committee, their ability to keep tabs on the status of the lake and informing how they decide to modify the firm. And then we also kind of delve into different investigations to try to understand South Arm nutrient maps, what's coming into the lake via surface water inflows. We've looked into atmospheric deposition of nutrients, so really trying to figure out how nutrients work in the system, what are the abiotic drivers of productivity in the system. So that's kind of what we strive to do with this partnership. Okay, I'll quickly go with kind of an inventory of the samples we collected last year. So in water year 2023, where we set a target to collect 8 to 9 samples per year at all of our inflow sites. That amounts to about every 6 weeks. So we met our target for the breach and for our inflows. Like I said, we didn't hit any, we couldn't get the stream flow page to quite work. So we didn't make it out there. And we stopped seeing flow from north to south of the breach last May. So we're limited in samples there because there was no flow. And then this year we're on target. We've gotten a couple of sample rounds so far. We're on track there. In terms of open water samples, GSLEP did 10 last year, which is pretty good, almost every month. And then this year we're on track. We've done 2 so far, actually 3, because we're picking 1 up too. We're doing great. All right, and so nutrients, in terms of the data we're generating, we are continuously sending samples to our lab every month. Unfortunately, the lab is not reported data from February 7th. And I know that that was a concern for Gary, the timeliness of the data. Oh, sorry, stop.
What happened? Someone stop sharing. Okay.
Stop.
That's better.
So this in the whole.
Okay, back to you. So we're sending it to the lab, as we always do. The lab is having a hard time generating the data and getting it back. So our most recent measurements are from February 7. Here is.
Yes, just say that.
I did one.
Like it's actually. It's true, does.
After we load it.
It's very hard. Only a handful of people that know what it is.
I think. I'm trying to think, I've seen-
So here are what we have is, all right, so from Y 2016 to present, on the y-axis I'm showing the concentration of a constituent in the other polluter associated for phosphorus. The top panel plot is nitrogen species from ranging from total nitrogen down to our inorganic forms of nitrogen, and then phosphorus on climate. So the triangles represent the USGS generated data here. They stopped in February, so just to give you a sense, obviously we're used to see the deep samples in this darker blue, kind of when we have a deep brine there, they're elevated, and then in shallower nutrients are typically more so lower concentration. So we're pretty, I'm pretty frustrated with our lab currently. The costs have gone up, as we've all discussed. The timeliness of the data is a huge problem. And so as of June, so when USGS is out on the lake cycling, last June, we collected a subset of samples and we're investigating in a completely different lab. So we have been working with our colleagues at the working in San Francisco Bay, and they recommended another lab. So you can see that, but it's the Chesapeake Biological Laboratory, part of the University of Maryland. They've been sending saline samples there to be analyzed from San Francisco Bay. And so we collected a in June, and the data are shown in these circles kind of at the end here. And while the data appear to be kind of in line, they're not like all over the place. They tend to be in agreement with our historic records. Because I don't have the data from USGS that compare the samples to directly compare, we still need to do that. We want to do a rigorous comparison of how this data is analyzing their nutrients and if they're comparable to what we see from our lab. So just to let you know, that's all in the works. And we collected another subset of samples this fall to do the same thing. And I'm harassing the lab to get the data from them. So I apologize for this. I know that many people want to see and use this, but we're looking actively at other alternatives for this. And a couple of benefits, well, a huge benefit could be the timeliness. We'll get the data in a more timely manner, but also if you kind of look at the nitrate nitrite value, so USGS detection limit, I think, is around 0.04 millimeter per liter. It looks like this lab can actually get lower. So in some of our cases of inorganic nutrients, we're hopeful that we can actually get below detection limits we're used to seeing, which would provide more use for fisheries. Okay, now switching gears to salinity, I'm showing data from two sites in Harrington Bay, one in Harrington Bay, one in Gilbert Bay. Our site in Gilbert Bay is in purple, and then the one in Harrington Bay is orange. Salinity is plotted in gram per liter on the y-axis, and our full records roughly from 2010 present. And the green line is lake elevation, so that corresponds to the secondary y-axis. Right. This is, I know you're all used to seeing this, but just to put our current moment into kind of historical perspective, we're sitting kind of in the middle of this optimal salinity range of brine shrimp. Our most recent measurements we have are from November 6th. They're around 144 to 140 grams per liter as measured by density and distribution of state. So as I think we've seen the low like elevation for the year, I think we're going to start to see salinity starting back up as Kyle alluded to. So we could. And other recent salinities we have are in Saltier, Serena got us a sample from December 4th, and that value is 137 grams per liter. And Utah Geological Survey also got their results in mid-November and also observed 137. Here's the kind of the same plot just zoomed in. So I'm showing from October 2021 to present, just to kind of give you an idea of the fluctuations you've seen in the recent past. All data are plotted here from our core GSLEP site. So as of November 2021, we started to get really concerned about salinity. Saw a pretty poor run-up here where salinity is limited by about 5 to 10 grams per liter. So not much dilution in that season. As Kyle kind of mentioned last November, we were seeing really high salinities, around 186 grams per liter. We saw an awesome runoff this year, and that led to dilutions of over 50 grams per liter. Huge declines this past season. And then during the evaporation season this year, we saw concentrations come up around 10 to 15 grams per liter. So we're, again, still in a really nice place currently. Relative to last year, salinities around 40 to 45 grams per liter more dilution. So just wanted to give you a sense of that recent history. And also wanted to highlight that we're seeing pretty low mix conditions from these 4 sites. We do see more dilute concentrations, of course, at our 2267 site, which is where the bear comes in, and slightly more dilute concentrations for fairly low mix conditions. So now I'm going to pass it over to Serena. She's going to kind of go through some of our data analysis tasks that are outlined in this report.
So I'm Serena Siegel again, and I get to do some work on the Great Salt Lake with Christine. I'm pretty excited about it. So, again, we have some key objectives this year for the work plan of 2024. What I'm working and focusing on is just assessing the current monitoring that we're doing on the lake, and then provide recommendations to streamline future monitoring patterns. So again, we want to be able to look at what we have and be able to see if there's anything, if there is any fat to trim off, and where that fat could possibly be to save us money and to effectively assess monitoring on Great Salt Lake. So we have 4 objectives. We want to assess seasonal variability in the South Arm, looking at the red fill ratio, and that's mostly where we'll be presenting some preliminary data on how we're looking at, and then we also want to conduct sensitivity analysis of inflow nutrient sampling, evaluate spatial and temporal variability of the South Arm nutrient concentrations, and then assess the effects of decreased sampling frequency and locations in the South Arm. So again, looking at what we have, looking at the data from the past, and seeing if there is any place seasonally or spatially, if we could cut back on monitoring, and maybe we won't, and maybe we will. So that's what we're investigating. Okay, so just backing up and reviewing red fill ratios. So red fill ratio is a stoichiometric ratio of essential elements, so carbon, nitrogen, and phosphorus inside phytoplankton cells, and the ratio of inorganic nutrients in the ocean. And that is from oceanography. So the typical ratio that is looked at for carbon, nutrient, and phosphorus is 106 to 16 to 1. And again, that's the most commonly used value of a red fill ratio. And that typically looks at total nitrogen and phosphorus. And emphasizing that we'll be looking mostly at that nitrogen to phosphorus in these we have done some research and continue to do so. But looking back, Volosky et al. States that phytoplankton in the lake growth is limited by the availability in the Great Salt Lake. And for this study, inorganic and P ratios were used instead of that organic ratio, and I'll talk a little bit more about that. But also, nitrogen limitation was found in both shallow and deep. So if we look over here, these were pulled from that Volosky et al. 2011 paper. Red fill ratio here over the y-axis and the time axis. This dotted line right here is 16, so that's that ratio right there for nitrogen. And then the dark bars are the deeper samples, the deeper nutrient pools, and then the light bars are the more shallow nature pools. We can see that that is consistently below that 16 to 1 ratio. This is just over years. And again, right here, that dotted line is a 16 to 1 ratio. Red field here on the y-axis, we're on the x-axis. And over the years, it does stay below that ratio, 16 to 1. So from past studies, we had an idea that the Great Salt Lake is limited. So we wanted to just look at the data that we have and see if that's what we're seeing as well. We looked at the GSLEP sites. So again, that 2565, 2267, 2767, 3510. And again, we are mainly looking at doing not total nitrogen to phosphorus, but looking at dissolved inorganic nitrogen to soluble reactive phosphorus for the DAN and SR instead of total. You'll see some total on the slides, but just because of, yeah.
Just curious, what's the kind of distinction or difference between using the inorganic? What's the upgrade using these versus the other?
So why are we using one
Yeah.
versus the other?
Yeah.
We've been discussing this, and we recognize the Great Salt Lake. There's a lot of nutrients that aren't bioavailable, and so that's why we went with this approach instead of using a total. Okay, so over here we have inorganic, so that the DIN versus SRP. And then over here, we also look at total ratios. And then on the y-axis, we have red field, and then a month on the x-axis for both the inorganics and total. And then here is the depth category. I separated the depth into shallow, deep, and transitional, just to look at those. Because we tend to have samples that are shallow, and then we sample at a deeper nutrient pool. We do have some transitional samples. So here, we can see over here with the total ratios that there is a pretty good distinction, especially if you look at the shallow, which is in this more pink color, versus the green color that are the deep samples. And then that line 16, I should have listed this slide, the 16 would be down here. And then you can see that these inorganic ratios are lower, that 16 will be right here. So there is a difference between looking at the inorganic and NSP ratios and the total ratios right here in the little bit of values. And you don't see as distinct of a separation in those shallow to deep samples either. And then we wanted to dive into this inorganic ratio some more. There are some histograms over here, inorganics again, total right here. This is count on the y-axis and red field ratio here on the x-axis. This green line right here on both graphs represents that 16 again. And you can see that there are more samples below that 16:1 ratio in inorganics, and there are a higher amount, especially in that shallow, above that 16:1. As we've been looking at these, we've also looked at different papers. There's variation in red field ratios between marine environments, of course, and then also lake environments. And then when you're going from a more marine to a terrestrial environment. And some of those provide, mostly there's a lot of variability that can happen depending upon the environment that you're investigating. And so what we're trying to do is to see what is the red field ratio of Great Salt Lake, what kind of category does it fit into, and if it fits into a specific category. So again, looking at the inorganics, these two plots, red field ratio on the y-axis and the date on the x-axis. Deep samples are these green dots right here, shallow samples are these red dots, and then this line represents 16 once again. So if we look at the deep samples and we look at it in fractions, 33% are above that 16 line, indicating that they could be feed limited, Over 67% of those samples are below that line, indicating that they are unfit. We go over here with the shallow samples, 19% are above that 16 line, indicating phosphorus limitation, and then 80% is below that line, indicating unfit. So it is looking like a Great Salt Lake is in fact an unlimited system. But this is preliminary data, so we're still gonna continue to investigate this and cool. So again, this is just the beginning. It's a really intricate system, as you all know, and a really interesting system. So we're excited to continue to look into these problems, not problems, but into this science. So we're excited. Now we're gonna hand it back over to Christine.
Yeah, I think we're ready for that. Let's talk about a question.
I do have one question on that.
Yes.
So that particular chart right there, have you looked at or do you plan on looking at the spatial variability?
Yeah.
Of previous 19% of our potential environment inflow sites or?
Yeah, so I just added that along with you this morning, so that's definitely one thing that I sent to the back. Yeah, spatial variability. Yes.
The importance of the salinity measurements, the long-time measurements, and how it's helped us, inform the Salinity Advisory Committee of actions we needed to take. Super critical and important right now, but I think in terms of nutrients as well, these long-term studies, not only do they inform the model, which is sort of indirectly supports the management, but I think we've had more recently a direct management action where the long-term nutrient data have pointed out that we replace about, I think it's around 8% of the dissolved nitrogen on a yearly basis on average, or not replace, but about 8% of the dissolved nitrogen pool is brought in through inflows on a yearly basis, which is very significant. And so rather than trying to reduce the nutrient outflows into Farmington Bay, that created, some of the problems with the blue-green algae and the cyanotoxins. We decided to actually move that outflow directly into the hypersaline part of the lake, allowing those nutrients to continue to flow into Gilbert Bay where they're really needed, rather than trying to limit those nutrients. It was really a win-win management action, and it was a result of those a direct result of those long-term measurements that we could make that decision. So I just wanted to point that out to the group, how important these long-term measurements really are, I think, to GSLEP and to inform us of what's going on the lake and how we can manage it.
Thank you. Yes.
Is there any coordination with sort of the funding from the Saline Lakes bill and Scott and IWPAA? Is there any coordination looking at these values in other saline systems?
It's a good question, Bonnie. I think we're still kind of honing in on what exactly the objectives of Saline Lakes will be.
Yeah.
There hasn't been talk about exploring nutrients in other hypersaline systems like this, but I think it's a great idea. I think probably because of the difficulty of monitoring that information. A lot of them are really hard to get to, and having, we, like as Thomas pointed out, we have the luxury of this data set. We're committed to that, but in many places, it's not as readily available.
That's a good point, but it does become a model for other places.
Yes,
I think
exactly. And I think
be
that's
really important.
why we've advocated to keep Great Salt Lake as a kind of essential piece of that program, is because we have so much to kind of not teach others, but to share with other systems. I will say that I think we're getting I can say we're honing in on a plan to really dive into Bear River Bay and understanding what's coming in from the Bear in terms of nutrients, salinity. They just did a synoptic this fall of conducting a bunch of measurements throughout that whole system. And how Saline Lakes is really going to dive into that is how are different nutrients and habitats evolving through that space. And what's really fun about it is we get to go from freshwater system of the Bear and these wetlands and carrying it through the South Branch to this hypersaline. So it's this full water chemistry gradient that we're trying to capture there and study really intensively. So that's one thing that Scott's pretty serious about pursuing, just so you're all aware. And I think that will inform this.
That's brilliant. Yeah.
Just curious, speaking about their, the wetlands, and I'm just curious if, you guys are looking at, you know, how these nutrients are moving through, for example, the refuge, and how the refuge is, because the refuge is really, we're looking at, you know, how can the refuge be managed differently to manage it better, you know, the benefit of the lake, the refuge, and specifically the human populations. I'm just curious, are you guys working with the refuge to do the nutrient monitoring through their elements?
Yep, those are part of the semantic. And actually, they were able to just get funding from the water trust, if I'm getting that right. And so we're hoping to leverage that as much as possible and kind of work with those synoptics that they're funding to be in the refuge. So they're more on the bear, I think, more on their canals and the bear, but we're hoping to time it with their efforts to actually be in the refuge, doing exactly what you're doing, nutrients, really basic habitat surveys to understand how water chemistry in terms of salinity and nutrients dovetail with different habitat types or productivity metrics. And yeah, really trying to get into the refuge too.
Okay, great. I'll talk with them about maybe putting together, have you give us on, we have meetings, so it's not review the updates. Great. And then it's also people with the, State of the Lakes initiative, so it's people in Colorado, Oregon.
Perfect.
Yeah, so great.
We did have one comment too in the chat from Linda Freitas. Sorry if I mispronounced that name. She said, or they said, great mention of the North Davis Sewer District discharge pipeline into Gilbert Bay keeps the water coming into the system while addressing the nutrient concerns in FB.
Thank you.
Any other questions for Christine or Serena? All right. Well, we'll shift over to Dr. Belowski.
How are you gonna call me doctor?
Doctor. Mhm.
Just doctor.
Doctor.
Is there a doctor?
I don't know.
Yeah.
Yeah, it's whenever you're touching my molecular biology, whatever that means.
See, also seeing the notes though.
I used to roller skate. Okay. It doesn't work.
Okay, keep going. Okay, what I want to talk about today is,
Yes, that's.
am I good now? Okay, what I want to talk about is, first of all, the phytoplankton dam that's here. And I talk out to my new technician, Leanne Chambers, who's online today. She's picked up counting the phytoplanktons since September, and it's been a strange year.
Yeah.
Kyle started that it's been strange, and I'm going to continue on with that and try to explain some of the things that the model has flopped on with this year that points out things that we haven't considered in the past. And in part, it's nitrogen that we're talking about here, and dilution, concentrations of the nitrogen. But anyway, one of the things that Kyle pointed this out is we got a peak, a real high peak in chlorophyll, phytoplankton abundance in the lake, and then it crashed much faster and more severely than the 5-year running average here. And it stayed lower over the period than the 5-year running average. That's the observation. So this is the driving productivity of the open water. Second thing that we see here is that we actually got a spike in diatoms, bacillariophytes in the lake. And we got a spike, a smaller spike in the blue-green bacteria, the cyanobacteria, sorry, Bonnie.
Yeah, I messed up on that one too, didn't I?
But you can see that the cyanobacteria after that were much lower than before. So we had some effect that we haven't seen in the past, last 5 years, in terms of the composition of the phytoplankton. But overall, Dunaliella, the chlorophytes have dominated. So this is the important thing right here, this real high peak in the phytoplankton abundance and then the crash and staying down low. This is the data that Kyle presented. And what you can see here is we came into the year with very low compared to the last 5 years cyst numbers, and cyst numbers this fall have not reached as high a level as we've seen in the past 5 years. The nuclei spiked and then came way down and didn't stay as high as they normally have in the last 5 years. The juveniles didn't hit as high a peak and went down low. Adults got higher than in the past 5 years and pretty much stayed the same as we've seen over the 5-year period. So there's been some real changes in the annual cycle of the shrimp population. Key here to think about is that if you look at this, this is females with eggs, live young being produced, much higher throughout the year this year than on the last 5-year average. Cyst production lower than what you expect, or higher also than what's on the last 5-year average. But what this probably tells us is that, when you just put this into a context, this high live young production probably is due to the high chlorophyll availability. Cysts aren't produced until you get some starvation. The problem is the food per individual in the population came way down and has stayed down lower than it has over the last 5 years. So once they starved, there wasn't as much food there then for the production of cysts. And you can see that the cyst numbers stayed low. Let's look at this through the lens of the model that we've been talking about in the last few years. The maximum values and the minimum values being predicted, well, the maximum values match up really well that are predicted by the model, the red bars, compared to what is observed out in the lake. In particular, if you look at the maximum cysts, they're right on. If you look at the nuclei at hatching time, it's right on. Maximum juveniles is not far off, and maximum adults is not far off. Minimum cysts, the model predicted much lower than was observed. And the chlorophyll, maximum chlorophyll was right on, but the minimum chlorophyll was way lower observed than what the model predicted. This is an important thing that that the model is not dealing with. 3 things have to be included in the model now after looking at it with this year's data, compared to the data that we used or to examine the model in the previous time periods. One thing is, and I pointed this out last year with the high salinities, we need to better include the effects of salinity on reproduction. And that, as I pointed out last year, depends on not just what the salinity is for the female, but how much the salinity has changed over time for her. So let's say the salinity last month versus the salinity this month. Something simple to include in the model that takes into account the stress that she has to deal with in terms of changing salinity. And I used that last year, built that into the model last year for the high salinity. But it didn't include it in the model for salinity going the other direction. This year, going from high salinity to much lower salinities.
Are you saying that women are the most important part of this equation?
Of course, in ecology, population modeling, women, females are the most important because they're the productive part of the
I
population.
just felt this feminist surge in your data. I wanted to recognize that.
And in the parthenogenic populations, they definitely are.
Stop talking.
Can I say that in Utah?
Okay, next thing that has to be included is a maximum reproduction. The model does not include that. If you give females lots of food, there comes some point where she cannot continue to produce more and more and more eggs or cysts. So the curve, instead of going up like this, starts flattening out. That has to be included. And with the high food that we had this year, the females couldn't keep up with increasing their reproduction. They hit that maximum. So another thing that has to be added to the model that we haven't seen in previous years. This one was the hardest one to deal with, nitrogen. Because what happened was, in the model, you put in the nitrogen concentration that was there when there was high salinity, which means low volume of water, which means that the concentration of nitrogen is really high. But what happened? You flooded the lake with water in the spring. Your nitrogen concentration goes way down, and the model was built based upon time periods where that difference was not that great. This year, there was a big change. This leads to other problems that I had to deal with, or have to deal with in modifying the model, and that's the berm. Because with the flood of water coming in, the volume of the lake doesn't change the way it used to because you're not getting flow of some of that water into the north arm. So the volume actually gets bigger of the south arm relative to what Rob Baskins had calculated back then. So that needs to be tweaked a little bit in the model. It's a shame that the model doesn't closely predict these things, and where it doesn't closely predict these things, the maximum values it does hit. But the rest of the chronology over the summer is where it's off. That crack in Montreal isn't predicted by the model. These are corrections that need to be put in, but we learn by doing this. We see things that we hadn't considered in the past in terms of the nutrient, nitrogen, and the salinity dynamics going into the lake. But even putting these three things in here, there's another, I made some rough calculations. Even putting these three things into the model, it still quite doesn't work. And where it doesn't work is getting this minimum chlorophyll here. The heavy grazing by the shrimp is included in the model. So this drop here is not due to grazing. At least it wouldn't seem to be. Building in that decline in nitrogen with dilution, that should be built into that, but it's not giving you that same value. I'm going to make a suggestion, and we don't have proof of this. And your data, the USGS data, is not going to might be able to tell us what's going on here. I think that we've got some stratification in the lake, not a deep brine layer per se, but some stratification where we got some sequestering of the nitrogen to deeper values, and it didn't cycle then into the upper photic layer where the phytoplankton could use it. I think. I can't prove that, but that's one hypothesis that could get into explaining why we're off there.
How would the nitrogen sequester?
The bodies, as I pointed out before in the nutrient dynamics side of this model, which isn't included, that's another thing that I'll talk about in a minute. The bodies of the shrimp and and their pellets, their fecal pellets, sink down relatively fast. And if they get down low enough, and that's where they're broken down and the nitrogen is released, and you're not getting enough circulation there, it's not being brought back up. Dead phytoplankton is no problem because that essentially decomposes as fast as it's being produced and stays in that upper layer.
And it could be, Gary, that when you had the debrine layer, you know, these fecal pellets and these shrimp would get stuck in the debrine layer, which does get mixed up regularly when you have big winds. It could be that when these pellets become really benthic, they don't get mixed up as well anymore. I don't know.
We don't know, and this is something that the dynamics right now could be explaining why that chlorophyll A went down, and we didn't see the numbers of nauplii expected after they peaked, and the numbers of juveniles that we expected after they peaked. Okay, so then let's look at the model being added with the benthic side of things, the microbial-like side of things. We're collecting data on this. And some of the data that we're collecting are focusing on the brine fly larvae. And an undergraduate is working in my lab on this for a senior thesis. And one of the things that she's looking at, Teresa is looking at, is if you feed the brine fly larvae biofilm versus detritus, and detritus here is brine shrimp feces, is there little bricks that are falling down. You find that the fly larvae survive just as well on either of those foods. However, they pupate much better on the biofilm than they do on the shrimp pellets. Big difference, about 2 to 3 fold difference. And if you look at the harvesting, the consumption rate by the larvae, you see that on biofilm, they're consuming far more per hour as an individual than they are of the detritus. They're still getting detritus when they're eating biofilm because the larvae are eating their own feces as well. So there is some detritus being consumed in this case, but it's 80% roughly of the biofilm. So now we've got consumption rates for the larvae. We've got how well they're doing on detritus versus on the biofilm. So we've got much better data now to build into that side of the model for the benthos. We already have the growth rate of the cyanobacteria and the diatoms that make up the biofilm. One of the things I've completed so far is we had a manual, and John and GSLEP has this for the benthic side of the model. Some 50-some pages of a manual on how to use the model. I have a preliminary manual for doing the nutrient cycling side of the model. And just to show you where we're at, the manual gives all of the equations that go in. This is probably 20 pages right now. And anything on one of these pages that's highlighted in red like this is data that we're missing. And it doesn't mean we're missing it entirely. We just have some first approximations of those values. That's why the model can be solved. Those approximate values are in there, but we don't have good values yet. So now what we need is how quickly the biofilm, when it dies, decomposes. Simple thing that we can do. I imagine it's going to be similar to the phytoplankton decomposition rates. What we do is we freeze it, kill it, and then put it back into lake water and see how the mass changes over time. We've had problems in looking at decomposition of the bodies of the brine fly larvae. We have that data from experiments with shrimp bodies, but we're having some problems with the fly larvae. First of all, we started using the same number of bodies as we did with shrimp, but the fly larvae were so small, the sensitivity of weight changes was too great. Second thing that we found, and Leanne and I've been going nuts thinking about this, we're having a difficult time of washing the salt off of the bodies when we pull them out of the decomposition trials. So we're thinking we've got some ways we think that are going to do this, but this gives you some idea. Here's decomposition of fly larvae at 120 parts per thousand salinity and 20 degrees centigrade. We don't have all of this data like this that we have for the shrimp already. Okay, fecal pellets of the larvae decomposition. We haven't gotten to that one yet, but we did get it done for the brine shrimp. And you can see 160 degrees, 160 ppt and 20 and 30 degrees centigrade, huge difference, much greater decomposition than at other salinities and temperatures. So whatever it is, the bacteria breaking these things down do much better at about 160, and of course you'd expect at higher temperatures. So this is the next step we've got to deal with.
That's interesting. It's 60 to 10. It's like way up there.
Yeah. 10, everything shuts down once you're at 10. The shrimp shut down, the flies shut down. It's just very little. That's sort of like the cutoff point for all the biology going on.
But can that explain some of the phytoplankton changes as well? Because that salinity went down significantly from above 180 down to 130 this year.
Yeah.
If the decomposition rate is much slower at these lower salinities, then that could affect your chlorophyll as well.
Exactly. Yeah. So you're not going to be cycling the nitrogen as quickly. But these are the insights that the model gives us. Even though it may not be predicting things just right now, it's telling us what we need to maybe look at. And of course, Mike Conover sent us green feathers, and we need to chop them up and see how they decompose. And that is what I have. Any questions?
We do have some stuff in the chat. So
Okay.
Dr. David Richards said, our Farmington Bay ecosystem model quantifies feeding behavior and metabolism, consumer resource interactions, community assembly and disassembly, and then diversity, complexity, and productivity. That was the first comment. And then second comment was from also Dr. David Richards. We estimate that approximately 200 tons dry weight suspended organic matter is exported from FB and Gilbert Bay. Lots of brine fly food.
Sure. Yeah. And what we're working on, Teresa, the undergrad doing this as a honors thesis, senior thesis, we're trying to get at how much from fly larvae that we've sampled in the lake that you guys have sent us. We're trying to look using qPCR, molecular analysis, to see how much of the food in their gut is made up of the biofilm versus made up of detritus. And if we can't do that with qPCR, another possibility is destabilize.
But if detritus of species is going to be full of bacteria, so the molecular
Because
analysis is going to.
But we have the larvae in the lab. We can feed them pure biofilm in the lab, and we can feed them pure detritus in the lab, and that
And
allows
you can
us then
subtract the gut flora.
Yeah.
Okay.
allows us to sample or distinguish between the two. So it is a key thing to understand the larvae, how much of what they're eating is detritus versus how much is the biofilm. It's absolutely critical. I mean, we've gone over the years from thinking that they were totally detritivores to thinking that they were totally herbivores eating the biofilm, and now we know that they're a mixture of the two.
It doesn't surprise me because I think they're opportunists. But I am surprised at what we know about biochemistry at high salinity is that enzymes work less efficiently. So it surprises me that at the higher salinity, you would see more decomposition because the enzymes involved in decomposition have a higher kinetic rate when the temperature is warmer and when the salinity is lower. So that combination is kind of shocking to me based on what we know about salinity and enzymes.
I think that it's more than biochemistry of enzymes per se. I think, and we're not getting into this, I think that your composition,
You're driving the microbial community.
you're driving the
Yeah.
microbial community into a different composition, and that's what you're seeing here. That's my hypothesis.
Yeah.
I would agree with you. I would have expected lower salinity, higher temperatures leading to
Right.
greater decomposition.
But even the community structure, like at 120, should have more of the biodegraders than at 160. So I've got to read about that because I don't know that specifically, but that's really surprising to me. It's super interesting. Because it's
I
very
can't answer
surprising.
that.
Yeah.
It's an observation that we came up with, and it's appearing in everything we're doing. The
Yeah.
what was it? The pellets, I think, showed it to the greatest extent.
Right.
But bodies show it, phytoplankton show it. Every single one of the decomposition experiments that we've done have exhibited that same observation.
And most of the dudes in the microbial community that are doing decomposition, their optimum temperature is going to be, even though the lake is cold, it's going to be around 35. So typically the warmer temperatures, you're going to see higher decomposition levels.
Yeah.
And the lake should be smellier in the summer.
Oh, good.
Where's Jen?
Any other questions?
Yeah.
No?
So in the experiment, where they were spending more time grazing on the biofilm versus fecal pellets, is that indicative of a preference? Or they seem to prefer?
Well, it's not more time. They're eating more, mass wise. Okay? It could be preference. We haven't done any experiments yet with ingestion of both when in combination. And the difficulty in doing that is that you have to do the qPCR or a stable isotope to see how much they're eating too. It's more complicated. It was easier to do for the shrimp feeding on different phytoplankton species because you could count cells of how much was Ganelliella, how much was Euhalothaceae, the cyanobacteria, and how much was Nidsia, a diatom. So you could count things and separate them. This would require a much more difficult way of separating out the. And on top of that, you have to take into account the control because they could be growing, that they would grow without being consumed in many cases. So it's much, that can be done when you can physically identify what you're looking at. You can't do that in this case.
Thank you.
But that's a good question. Is there preference? Also, I would suggest that the biofilm, they can eat more of the biofilm because it's probably easier to scrape up than it is to crunch up the pellets.
Is this the biofilm you're growing on the tiles?
Yeah. And that's what we're doing. You're giving them tiles to feed on.
So when we're regrowing microbialites from dried microbialites, and we're putting them in lake water and seeing if we can if the mat is resilient, if they can regrow. Our first go through it, looking at the genetics of the microbial community, is we're getting different communities than what we see in the lake. Or that what we historically saw in the lake when the lake was bigger and more robust. So that's interesting to me. Like, I don't think it changes your results because I do think there are.
They were alive.
Yeah,
We didn't
Yeah.
kill them essentially or try to regenerate them.
right,
It was scrapings
right,
placed on the tiles.
right. But I would suggest that they might be slightly different than what's in the lake, but I might suggest that it also probably doesn't matter because they probably would eat what's there regardless. And as long as you have somebody doing photosynthesis, you're getting good nutrition.
That's
So,
right.
but
There's something they're getting from the photosynthetic elements.
we're seeing
that lets them do
filamentous
better.
cyanos that we don't see in like mature microbialites. So there's some just really, and the fungal composition is super interesting. So I'm just like, it's not a monolith, the microbialite community. It's really, but again, I don't think it changes. Yeah, yeah.
Do you think it's successional?
Yes, exactly. That's what I
Yeah,
think
that's
is
what I would
going on.
expect. It's
Yeah.
a exception
That's what I
in
think
the
is going
community
on.
composition.
Super interesting, but I don't know what to make of it yet. And I don't think it changes your data at all.
To be honest, I don't want to deal with that.
No, but you
I'll
don't
be
need
totally
to.
honest with you.
Look, you deal with the invertebrate poop and I will deal with the happy green boys.
Yeah. We do the green things too, so. Yeah. Anything else?
All right. Thanks, Gary. And we'll shift over to Lauren, our other star student.
That's great. A lot more, it's getting more and more.
Hi, everyone. For those that don't know me, I'm Lauren Head, and I am a PhD student at Utah State University under Mike Conover. You may recognize me before I started at USU. I was a technician for GSLEP, so this is not my first time meeting. But yeah, so I've been tasked with developing the framework for a water bioenergetics model for the wetland side of the Great Salt Lake. And so we've been working really hard for the past year in kind of developing our survey design and getting our first field season off the ground. So I don't have any results for you yet because we just got out of the field last week in November. But I'll be presenting kind of on what we've been up to and what we've done so far. I also just wanted to take a minute and GSLEP specifically have been nice and helpful in helping with both the on-the-ground fieldwork as well as the development, and my WMA managers that are in attendance for your cooperation as far as accessing your WMAs during the season. It's really been awesome. So yeah, I'll go ahead and get started. So for those that aren't super familiar, the general goal of a bioenergetics model is to quantify the availability of food resources for birds. In our case, we're looking at water birds, specifically waterfowl, and maybe a couple representative shorebird species as well. And you basically want to put everything that they're eating in terms of calories and quantify the amount of calories that are available to them while they're using the lake. So then there's kind of a use and an availability piece to this. So we want to make sure that we're assessing accurately what resources are available to birds in terms of food. And then we also want to know how many birds are these areas currently supporting. So what is the use of these food resources throughout the course of seasons and years. So we're hoping to quantify both the availability of food resources for this project and also evaluate how those food resources are depleting. So we're looking at this throughout the season so that we can assess how food resources are changing between seasons.
So this summer and fall, we've been hard at work and we've collected 480 samples of water column samples, soil cores, and submerged aquatic vegetation samples, which are kind of our primary food resources that are used by water birds in these systems. We've also been conducting point counts and foraging and a kind of independent foraging habit study for American radishes and stilts. But we'll go ahead and get into kind of the survey design for this bioenergetics piece, or the availability part of the study, which is sort of what these soil and water samples are getting at. The timing that we've chosen to look at this is in August, November, and April. So we go out to each of our 6 survey areas in all of these months, kind of in succession, and we basically go out and assess. We're assessing food resource availability. So in August, we wanted to kind of catch that period right before birds are arriving. So look at what's available to them kind of at the peak of the growing season before birds are starting to arrive for fall migration. We just finished up assessing food availability in November, which is kind of this period as birds are starting to prepare to leave the lake or prepare to overwinter on the region. And then we also are planning to go back out again in April so that we can assess what is available to these birds after thaw and as birds are starting to enter the wetlands for their breeding season. As far as our sites, we've got 4 managed impounded areas and 2 unimpounded sheet flow wetlands that we're looking at. Those are public shipping grounds, Bear River, Ogden Bay, and Farmington Bay. And then we're also looking at these sheet flow wetlands in Willard's Spur and Farmington Bay Ponder. So some key differences here we have in our managed areas. These are going to be obviously impounded units. So we're going to have much greater manipulation and control over water depth levels in these areas. And we'll also have more control as far as invasive species management and in the perpetuation of different waterfowl foods. In our unmanaged areas, that's going to be a lot more variable. We're going to definitely be seeing, greater variation in water depths between seasons and years. And we'll also see a greater range of different habitat communities because you have not just open water, you have these mudflat playa systems and emergent vegetative systems as well. So how we kind of tackled sampling all of this is we've essentially, in our managed areas, selected 2 impoundments. So this is an example of where we've been at public shooting grounds. We selected 2 impoundments. One, the impoundment that is in blue up here is a rest area, so it's not accessible to hunting. And then the other area, so this one right here, is our hunted impoundment. And we wanted to do this because birds obviously don't want to eat where they're being shot at. And so we predict that and have observed that we are seeing higher bird densities in our rest areas than we are in our hunted areas, which is going to influence the way that they're eating down these areas. So we wanted to make sure that we included both rest and hunted impoundment on both of our, on all of our managed areas, much to the dismay of our hunters. In each site, we basically divided our impoundments into quadrants, and in our managed areas, these are mapped along the deepest side of our impoundment. So we have a depth gradient, and then we're also making sure that we're evenly sampling within each of these impoundments. And how we actually sample is we lay a transect basically randomly within each of these quadrants, and then we evenly take 5 samples along each of these, along our transect. And at each of these sites, we're taking soil cores, water column samples, as well as a drag for submerged aquatic vegetation, so that we can start to quantify food biomass in each of our sites. Right now, we're taking 40 samples per area, so that's 20 samples per impoundment, so 1 transect within each of these impoundments. And mostly just based on like resource constraints, these samples are very time consuming to collect and to process. So this is about the most we can do, and it also literature has supported that this is the minimum variance that's required to draw conclusions of bioenergetic studies. Our unmanaged areas are a little bit different. This is kind of our snap for Willard's Spur. With these, we've sort of, since these are so much more variable, we try to map basically where we think the water is going to be using Landsat imagery. And then similar to our managed areas, we basically lay transects in each of these 8 quadrants as opposed to 4, and then collect 5 samples along each of our quadrants. Another thing to note about our unmanaged areas, obviously, is we have a diverse suite of habitats. So these are two of our pictures of two of our sites. So as you can see, it's not just open water, so the way that it is in these managed areas. We're also seeing areas of mudflat playa. We've got open water, and then we've also got this kind of like sparse emergent vegetation community that we're playing with as well. And yeah, we chose systematic for this, for our unmanaged areas, specifically because we wanted to make sure we were capturing each of these ranges of habitats, and the habitat mapping that we needed in order to be able to like randomly sample within habitats was just not up to snuff for what we needed for, as far as detail for this project. So once again, we collected 40 samples for these areas as well, and we may increase that next season depending on how our results look for these areas. I'm guessing that we're going to probably see more noise in these unmanaged areas. So now what we're currently in the process of doing is I've got 3 technicians that are working with me in the lab, and then I've got my field technician here, Kate, and we're working on basically sorting through these samples, running them through a series of sieves to sort of start to pick out different macroinvertebrate, tuber, seed, and plant resources that are available in these samples. So this is a super time-intensive process. That's probably going to be most of what we're doing this spring. But yeah, so we're basically trying to get everything down to the lowest taxonomic level possible. With a lot of our macroinvertebrates, that's probably going to end up being family groups. And then with our seeds and tubers and plants and submerged aquatic vegetation species, you should be able to get down to genus. So the hope is to dry and weigh these samples to get biomass estimates of food resources that are available to birds, and then we can convert these into calories that are going to be available to birds on a day-to-day basis. So that kind of covers our availability piece. And then the next thing that we've been working on is getting at this use piece as well. So hoping to contribute to some of these larger lake data sets for bird populations. And we've been getting at this by conducting monthly point counts for water birds in each of our areas. We're doing these for waterfowl and shorebirds, and swans and geese as well. And so basically we've been conducting these off of the dikes that surround each impoundment. In our unmanaged areas, we've been using the Willard Bay dike, which is what this is a picture of. And at our Farmington Bay site, we've been using the Animal Island Causeway, counting both sides of it. Basically, our protocol for this is we've been using a pair of range finding binoculars so that we can calculate distance to the bird. And we determine kind of a max range for what our binoculars can see. And then we count for at least 5 minutes and a 90-degree wedge. So we would look out at the area in front of us to reduce disturbance. And we essentially just try and get a count for the number of different species and the amount of birds that we're seeing in each of these areas. We try to hit at least 4 impoundments in our WMAs and at least 4 counts in our unmanaged areas. And then finally, we've kind of been working independently with some of Mike's, kind of in collaboration with some of Mike's funding. We've been conducting kind of an independent foraging habitat study for American habitats and black-necked stilts. Yeah, I do want to emphasize waterfowl are the primary goal of our bioenergetics research so far. We're hoping to include as many shorebirds as we can. But this is kind of an adjacent piece to that, quantifying food preference for avocets and stilts. And so the way that this worked, we only did this in Bear River Migratory Bird Refuge. And this is kind of a pair study looking at feeding preferences for avocets and stilts in Bear River Migratory Bird Refuge. So basically, as opposed to doing these systematic transects, looking at food availability, this was actually going out to sites where we observed birds foraging, and we took water and soil cores, water samples and soil cores using a stovepipe sampler to assess foraging resources that these birds are actively going after. And then we went about 1 kilometer down the road and did the same thing in an area where we did not see birds actively foraging. So we're hoping to use this to get better insights into what these birds are preferring to eat and how that's relating to this food availability side of the equation. So yeah, as far as predictions, we are observing in the field that hunting pressure does seem to be influencing the way these birds are eating down our impoundments. In our rest areas specifically, we were seeing a lot of pretty drastic changes in presence of submerged aquatic vegetation in the rest area from August to November. So they do appear to be eating that down, although we don't have any conclusive evidence of that yet. We also are expecting there be depth limitations as far as what's available to certain species. We know that shorebirds are not going to be able to forage much deeper than the length of their beaks. Dabblers are going to be limited to about half a meter. And then we have divers that can forage up to about 10 meters. So there's obviously going to be a spectrum, and we're going to have to find some way to limit food availability based on water depth. And then the final thing is I think that diversity is also going to play a big role here. Our impoundments are managed for waterfowl, therefore we probably will see a lot of waterfowl in our impoundments versus in our unmanaged areas. We have larger diversity of habitats, a larger diversity of water depths, and I expect that we'll see a larger diversity of species there. And then as far as future goals for the project, we're hoping to pair our work with some sort of GIS analysis. We would love to be able to create a super detailed map of water depth on the wetland side of the lake, and are working with Doug Ramsey to do so. We're hoping to do this for multiple years, so conduct this study over the course of at least 3 seasons is the goal. So we can get solid estimates both between years and during seasonality or between seasons. And then our hope is to eventually pair kind of our classic daily ration model, which is sort of the typical framework for a bioenergetics model, and start to maybe investigate some of the inputs towards more of an agent-based model. And those can be a lot more predictive as far as being able to plug and chug certain conditions. So yeah, just once again, I wanted to thank all of my funders, UDWR, the Division of Water Quality, Delta Waterfowl, Sports and Fish and Wildlife, and then Utah Wetlands Foundation, and just wanted to once again thank all of my field technicians and lab technicians who have been instrumental in helping us get this project off the ground. And yeah, also wanted to re-thank all of you. I've pestered many of you for meetings just to talk about various aspects of this project. So I really appreciated all your support. Any questions?
Fantastic.
So can you go a little bit more into what an agent-based model is?
Yeah, so it essentially uses kind of, I would compare it more to like what Gary's doing with the project side of the model, with the project side of the lake. It's a little bit more like takes inputs of like values that you know from other places and kind of helps you, as well as metrics of body condition from birds, to kind of help you predict how birds are going to respond to different food availability conditions. Yes.
Have you been able to work with mosquito abatement to make sure that they've sprayed within a certain time when you're doing some of your collections? Because the stuff that I did, I know it's been a long time ago, but mosquito abatement really affected our macroinvertebrate collections.
We have not observed them while we're out there. We haven't seen them while we've been in the wetlands, but we have not been working with them specifically. So I don't know. We've not worked with them.
You might just
Explain declines.
Yeah.
yeah, you may just want to just stay in touch with them and just see if you can get dates. So if ever you have a big hole,
Yeah, we can.
you can say
that. Yeah, no, that's a great point.
There's some chat stuff. So Dr. David Richards said, caution that bird abundance at Beak from Causeway will drop to near 0 once NDSD water is diverted. And then Linda Freitas said, would love to have an update of your work presented at the 2024 GSL issue forum, May 8th through 10th at the U of U. They will be in touch.
great. By the way, amazing talk. You give a great talk.
Yeah, well done. Yeah. Appreciate it. Enjoy listening to all of you guys the past couple of years. Cool stand here.
Yes, in your, when you do listen to this, I think it's August, November, April, is it like one day per credits?
It usually takes us 2 days per site, 1 day to do the rest of the comment and 1 day to do the summit. So we try and keep it as condensed as we can. Obviously things come up, and especially during the hunt, we are restrained to weekdays because we want to minimize the disturbance to the hunters as much as possible. So we do kind of operate on a Monday through Thursday schedule.
So is there any way to get like temporal variability? Because they're kind of snapshots. Specific ones sometimes. Do you take temporal variability water depth, salinity, or anything in the accountants could affect the kind of the snapshot stations.
Yeah, I think it definitely will. And one of the things that we are planning to use is like the depth gauges that are on these impoundments, because all of them are installed. That goes through Bear River as well. To sort of kind of get other estimates of that. And then we are, while we're kind of taking these snapshots, we are taking salinity and DO and temperature measurements, as well as humidity measurements. So we kind of have a snapshot and then are hoping to get some of them at least from these kind of water control structures that are installed on the dikes.
Are you, planning to do anything as far as, capturing aerial imagery or, you know, satellite imagery like for these surveys?
Yes, and we have just started to kind of get in, we're started some conversations with Dr. Doug Ramsey at Utah State, big GIS guy, specifically looking at submerged aquatic vegetation and kind of how that looks. And we have given him our dates, so hopefully we'll be able to kind of investigate those densities on the days that we're out there sampling.
The other thing I was just going to mention with Willard Spur, you know, there's a lot of information out there in that water quality study as far as the temporal dynamics of that system, which probably really affects food availability and foraging, habitats, and
Yeah,
it's a complicated system.
absolutely. And we are trying to, when we go out and conduct these unmanaged areas year to year, obviously these lines that we've drawn may change as to where we think the water actually is from year to year. So we do plan to redraw our maps with updated satellite imagery of where we think water is to make sure that we're kind of capturing those changes as they occur.
We can go out and like taking depth measurements.
Yes, we also have depth measurements from all of these areas. And that's hopefully also going to help us as we do go into this sort of like GIS relation to water depth sort of piece. We're hoping to use some of these methods or depth measurements to sort of ground truth that. Any other questions? Sweet. Feel free to catch me after the meeting as well.
Yeah. Does anybody else have any questions about anything that we covered today or any, want to mention any of the research that we're conducting?
I have to give a shout out to John.
Nobody.
Lauren
everybody shouts
has,
back.
has been a great graduate student, and she worked for GSLEP before she came, and John and other people there gave her a high recommendation. Without that recommendation, I wouldn't have hired her, and it was one of the best decisions I've made. So thanks for the good advice.
Hey, we're lucky that we get really good people all the time. So, and that goes for the whole group. So,
I'm gonna have to scavenge your ranks more often, I guess.
hey.
Yeah, we're happy to talk to
Thomas
your
has
really
done
good
that
people.
already.
Yeah, but that was retaliation for what you did.
Well, I'm not sure Jamie counts. I don't think that's
Sure she
fair
counts.
comparison. She texted me, so she may hear that. So. Okay, so I'm gonna just, before I set, the next, meeting dates, I'm gonna mention a couple of things. Marissa, I wasn't sure if you wanted to talk about the Great Salt Lake Basin Integrated Plan open house tomorrow. Is that?
Yeah, I can only say that it is tomorrow at 6 p.m. It's virtual. If you do have any more specific questions, you can reach out to Laura Brennan. She's the Basin Integrated Planner, so she has a lot of information. I will also make a plug for our Great Salt Lake Tech Team meeting next Tuesday at DNR. So a lot of you attend regularly, and it's open to anyone that wants to come virtually or in person.
So you can just go to the Water Resources website to get the link.
Yes, yeah, any link you click on the Basin Integrated Plan. I also forwarded it yesterday to all the listservs, so sorry for all the emails. That should be in your inbox.
Awesome. And since you spoke up, Anne, do you want Do you, I know at least from our perspective, the water trust awarded, some money to several projects that we're doing. Did you want to mention any of those or?
Well, I have to confess, so even though I worked for the Nature Conservancy, my role in the trust is over. I did all of the all the program writing and things like that. And so, TNC was not a part of any of the judging, the writing and things like that. So all the information that you can get on the website for those projects that were awarded, that it is on the website now. And, so the only thing that I can tell you is they're probably a month away from getting contracts out. So sorry, because we got one too. And so like, please, can't you hurry this up?
Right.
So probably at least a month away.
Yeah, well, I know we're grateful for some of the projects that were awarded, $5 million plus.
Yeah.
For
We were awarded just over $5 million for some big projects, Farming Bay and Ogden Bay.
And that's the stuff that DU put in, right?
Yes, and Ducks Unlimited was the one that put in these proposals for us, so without their help, wouldn't have got that. But,
Right.
Well
but
done.
These are all projects that are gonna upgrade the main infrastructure that flows through these WMAs and then puts water out towards the lake. So,
Makes it measurable.
what's that?
Makes it measurable.
And yes, will be measurable.
Yeah.
Two quick comments in the chat too.
Okay.
So Linda Freitas asked if there's any insights or updates on the eared grebes. And then there was Jeff Den Laker put a link to the Great Salt Lake Basin Integrated Plan of us. So that's in the chat.
So as far as the grebes go, I don't think I'm certain our count isn't done for this year. Anecdotally, based on what I've seen as far as on my flights, it's better than it was last year. The ear grebe, John, you probably have, because you do the count, so I'm not sure what I'm talking. So
I got the impression that anecdotally, when we were doing the survey, over more concentrated along the south and north of it to 3 Mile Island. And it's kind of hard to because these, and they're so restricted in the area, but seemed comparable to last year. I guess around 2 million reads. And I've been checking radar, and they doesn't seem like they've started migrating.
yeah, so one thing I will say is because of the Salinity Advisory Committee and the change that in the berm that was made, invertebrates respond really quick to those changes compared to birds. Birds, there'll be a lag, usually a year lag before you see a response to any management decision. So we did see more brine flies this year, better brine shrimp populations, primarily because of that shift in salinity with the runoff in the berm installations. So those tend to respond a lot quicker, brine flies and brine shrimp. But grebes, probably it's comparable to last year, so it's at least not taxing them this year because they do have brine shrimp to feed on. So,
But we don't know what the recruitment was or anything like that for a couple of years.
no, and the numbers, I mean, Gary's talked about this in the past, is there's usually a lag in how the response there. The interesting thing that we've seen is, since I started working on the program, typically you would see maybe 1 million eared grebes here when we first started. As we got more refined with the management for the brine shrimp, that population just steadily increased to a point where we were seeing 4 to 5 million eared grebes per year. And I think we kind of maxed out the opportunities for brine shrimp because of the solid management for the brine shrimp population. the cooperation with the industry that basically increased the ear group population here at Great Salt Lake instead of half of it being at Mona Lake. I think we take the majority of it now. And when Mona Lake was dropping, I think we had 90 to 95% of the ear group population here because we had room to grow it. So, and let me just say this because, and Thomas mentioned this maybe a couple meetings ago, talking about how effective managing this system, but also the knowledge that we've gained through not only the technical advisory group, but the Great Salt Lake Tech team, the Great Salt Lake Advisory Council, the Salinity Advisory Committee, the Great Salt Lake Basin Integrated Plan. All of those things to me have informed and are huge undertakings like the integrated plan. I mean, I think something similar to that was mentioned when I first started as an avian biologist, and nobody wanted to touch it because it was so immense that it was basically impossible for anybody to see that it could even be done. And these things have, through the support of the, legislative sessions more recently, and just leadership throughout all of those areas have made a huge difference, in my opinion. Maybe I'm off, and I know you mentioned how the tag has we've grown knowledge here, and the decisions that we've made have been a positive impact for wildlife people around Great Salt Lake. I think a lot of these groups that have been started and the progress that they're making, to me, is a big deal. Is a huge deal. And I guess I'll put that on record because I think you put it on record last time. So I've been nothing but impressed. It used to be that, and sometimes it's a little success breeds more work, I guess. But it used to be I had to beg people to listen and pay attention to the lake. That's not the case anymore. It's getting a lot of attention, and it has created a lot of work. So thankfully, we have a few more folks now starting, so we can divvy out some of the work. But I'm sure, USGS has had to deal with a lot of things in a lot of different groups. You probably give the same presentation over and over again, or similar ones, because there's so many different groups. But to me, it's been encouraging to see the knowledge grow and the decisions that have been made for the lake, and it's made a huge difference.
I'll just add something to that, John. Is that I think in our day and age, we're often asked, well, what's the immediate outcome going to be of a study that is being proposed? And I think we're an example at GSLEP and the tag, where long-term studies don't always a priori, inform us of what an outcome is targeted, but that a posteriori you actually do get some outcomes that are really, really important. And we just don't always know ahead of time. And I think it's a great example of that.
Amen.
Yeah, that's what I was thinking watching Eric's presentation, that, this has got to be like one of the most long-term, highly detailed, so finally, dissected and just what you can look at of, any ecological model from anywhere. And it's all based on this really applied science that is, the outcome is being used, daily to manage things. And then I think it set us up for, when the lake kind of came into crisis, we actually have an understanding of, what it was like before and, being able to track it as it's moving through and, being able to actually understand, well, what is this management doing and being able to, demonstrate that to the people who are funding it. Yeah, this is just an incredible program. And I was just going to mention I'm retired at the end of this year, and I think that this meeting is probably one of the things that we missed the most because I feel like this has just been the greatest science, examination, and it makes you think deeply about every little thing about, deposition and nutrient transport and biofilms and brine shrimp poop. and yeah, so I really think that this has been a great year to really start this about. It's been a pleasure to be part of it.
Well, happy retirement, Chris.
Yeah. Maybe I'll get out on the way.
I want to share those comments, but I want to put them in a global perspective. If you look at hypersaline lakes across the world or throughout North America, they're all suffering. If we look at North America, when I started this project 30 years ago, there were more grebes on Mono Lake than here. There were more grebes on the Salton Sea than here. In the interim, Salton Sea has collapsed. Grebes no longer use it. Mono Lake has collapsed. Grebes in large numbers no longer use it. And so, in essence, the Great Salt Lake has been managed in such a way that it is now basically the last bastion for a lot of these bird species that are dependent upon hypersaline lakes, such as phalaropes or avocets and stilts or grebes. And so, we have now millions of grebes on the Great Salt Lake. We never used to, but they're here. So the fact that they are here speaks really well. Hats off. This is one of the few success stories as far as hypersaline birds go. But it also is scary because this is the last bastion. And heaven help us if we ever wake up and there are 2 million dead eared grebes on the Great Salt Lake. So great job, but it's also the fact that this isn't duplicated elsewhere is scary. So great job.
Yeah.
For everyone in this room, everyone who has contributed, we've done fantastic.
And
It's just unfortunate that other places have not.
We jumped in the same way.
Yeah, and we are like the last basket, and we're putting all our eggs here. So, one other thing that I mean, and just because we talked a little bit about the Salinity Advisory Committee and how the berm has made a difference. I noticed just recently, I'm going to make this observation because we talked about it a little bit, which was there's this freshwater lens that hooks around along the causeway, and I flew day before yesterday, and there must have been, I don't know how many tens of thousands shovelers all along the causeway. And they were feeding on that freshwater lens that was running along there. Because what else? I mean, why were they all stripped along the causeway? You got to see that too, which was interesting. But that is exactly what we've been talking about in the Salinity Advisory Committee, is that water heading right along the causeway. And I can honestly say that when that Salinity Advisory Committee was started, I was like, what kind of stupid committee is this?
One more.
Yeah, exactly. And that's how limited my foresight was. And I feel like that's been one of the best, most productive groups that I mean, obviously this one too, but, that one has made some really, good decisions, in the recent years, and I never thought that that would be the case, so. Anyway, anybody else have anything that they want to mention before we conclude and get some lunch?
Regarding that.